So here we go. I mean, like just general consensus is that the smaller the particle gets, the more harmful effects it has, just because it has, for example, it has more surface area compared to volume. And it's not just identifying these particles, but you're also the measurement is also complicated by the fact that you're identifying these in a very complex matrices, like biosolids and in human bodies. So could you also walk through like what the procedures like, what the limit, again, what the limitations are? Can you give us more details how these are measured and what the challenges are?
That's a great question. So I would say that the challenges depend on what matrix you're looking at. Drinking water is a relatively clean matrix. And so typically you don't have to do a lot of processing of the sample before you characterize it. So I would compartmentalize detection techniques into three different stages. One is the sample processing stage that includes sample collection and how we process the sample. How do we load these samples that potentially contains these microplastics onto a platform? Typically, we would use a filter to load these microplastics or to separate it from the water and other constituents that are present in the environmental sample. And then you have the analytical technique that actually detects and identifies these micro nanoplastics. And then you have a post-processing techniques where you get these signals and these spectra, as you will, from these analytical techniques, and then you match it with an existing library of some sort. And then you say that, oh, this looks like a polypropylene, or this looks like a polyethylene, and so on. So all these different stages comes with its own challenges. When it comes to a simple matrix, I call it a simple matrix from an analytical perspective, like drinking water. The initial sample collection processing stage, the only thing you have to be mindful of, the sample does not come into contact with any plastic material. You use non-plastic material to collect the samples, and you use apparatus such as vacuum filtration apparatus to load the samples onto a filter that does not have plastic materials. So more often than not, that's the main concern with that. But when we talk about more complicated samples in the other part of the spectrum in environmental samples like biosolids or sediments, you also have to deal with really large amount of other constituents that are present in the sample, like organic matter, sediment particles, inorganic particles,